Assalamualaikum and good day everyone. Okay, so we will continue second part of this chapter. Okay, we are on the probability chapter. Okay, last time this is the last slide we have. Okay, now I will demonstrate some of the answers. Okay, so n is 36 plus 44 plus 15 plus 20 plus 5, and that's 120. Okay, the machine dispenser randomly selects one gumball. What is the probability that the gumball selected is green? Okay, so we can write probability of G. So we have how many green? We have 20 green gumballs, so it's 20 over 120. And that is 0.167. 167. Okay, what about the next question? Probability that the gumball is not green. Okay, probability of, how should I write? Okay, G bar. So this is the same as 1 minus probability of G. Okay, so this is 1 minus 20 over 120. So this is 100 over 120. And this is equal 0.83. Okay, what about not a color in the flag of Malaysia? Okay, not the color. Okay, color in our flag is red, white, blue, and okay, so that's the color that we have in our flag. So for this question, we should consider the probability of getting a green or an orange. Okay, so this is probability of green or orange. Okay, and that's 25 over 120. Zero point 2083. Okay, what about the last question here? Red, white, or blue? Okay, so this is what is the probability of red, white, or blue. And as we can see, this is equals 1 minus probability of green or what or orange. Okay, so this is 1 minus 25 over 120. $95 over 120. 0.79792. Okay. Okay, now let's look at what is a Venn diagram. Okay, the Venn diagram can be used to illustrate the relationship among the events within the sample space. Okay, the shaded area shows, okay, this is the shaded area. This is event A. Then we have complement of event A. So this is the shaded area. Okay, for the complement. Okay, that's why we have this formula. Probability of A plus probability of its complement equals 1. Or this is equivalent to 100%. Okay, because if you combine probability of A, which is inside the circle, and also outside the circle, the whole thing makes up 100%, or the whole area. Okay, the union of two events represents by A, okay, A union B corresponds to event A or B. Okay, and then, okay, this is the union. When we have union, we shade everything here. A union B. Okay, the intersection of two events represents by A and B corresponds to event A and B. Only the intersection. Okay, hanya tempat yang bersilang sahaja kita shade. Okay, example 1. Okay, the diagrams represent a class of children. G is the set of girls and F is the set of children who like football. Decide which diagram has the shading which represents girls who like football. Okay. Girl who likes football. So I would say diagram B, because the intersection region here represents girls and football. Okay, girls who like football. Okay, and then we have next situation, girls who dislike football. Okay, so it would be diagram D. Okay, diagram D. Because if you think it's C, okay, outside the circle does not represent girls. Okay, maybe this represents for boys. Okay, so that's why the answer for the second condition is D. Okay, and then we have example 2. Okay, in a class there are 8 students who play football and hockey. Okay, so these 8 students play both, okay, football and hockey. 7 students who do not play football or hockey, 13 students who play hockey and 19 students who play football. A student is selected at random. Draw a Venn diagram to show the events and the outcome. Okay, so basically we should have two circles. Okay, football and hockey. And also when you draw a Venn diagram, you must have a square. Okay, to represent one whole situation. Okay. Okay, so you have border. Okay, so 8 students who play football and hockey. So there are 8 students. Okay, 7 students who do not play football or hockey. Okay, I will reserve for this one. Okay, and then 13 students who play hockey. Okay, so for the whole circle of hockey, there are 13 students. Since we already have 8, so the remaining is 5. Okay, and then 19 students who play football. So once again, for the circles, for the circle marked with a F or football, the total is 19. So since we have 8 inside, so the remaining is 11, and 7 should be outside here, outside the circle. Okay, we are done with number 1. Okay, how many students are there in the class? So as you can see, there are 11 plus 8 plus 5 plus 7. And that's 31. 31 students. Okay, find the probability that the selected student is not playing hockey. Okay, so that will be not playing hockey, 18. Okay, so I simply refer to the Venn diagram. Not playing hockey. Oh, but it's the question is asking for probability, so be careful. It's not asking for the number of students. Okay, so probability of not playing hockey is 11 plus 7 over 31, which is 18 over 31. 0.5858. Okay. Okay, playing football or hockey. Okay, for question B, playing football or hockey. Okay, so remember, for the union, we will cover both circles. Okay, so we have 11 plus 8 plus 5 over 31. Zero point 7. And the final question, playing football and hockey. So this is straight away the middle value there. So C is 8 over 31. And that's 0.258. Okay, and then for example 3, maybe you want to try on your own. Okay, draw a Venn diagram of the illustrated situation. Okay, and then answer the question. Find the probability that a selected student is studying all the three subjects. Okay, ni typo kat sini. Okay, a tree diagram is a simple way of representing a sequence of events. It is a visual display of the outcomes from a probability experiment by using branches that originate from a starting point. Okay, tree diagrams are particularly useful in probability since they record all possible outcomes in a clear and uncomplicated manner. Okay, tree diagram for the experiment of tossing a coin twice. Find the sample space for the gender of 3 children in a family. Okay, I have demonstrated a tree diagram for the second question. Okay. For today, I will demonstrate the first one. Okay, tree diagram for the experiment of tossing a coin twice. So basically, for this experiment, you have one coin, okay, but you will toss it twice. Okay, so you will have this tree diagram. Okay, first toss and second toss. Okay, I hope you still remember about head and tail. Okay, representing the surfaces on a coin. Okay, so basically during first toss, since you have two surfaces on a coin, so basically you will end up with either a head or a tail. Okay, same thing for second toss. You will end up with either head or tail. Head or tail. Okay, now as you can see, by drawing a tree diagram, you can straight away list the sample space straight away. So basically the sample space is 4. There are 4 options in the sample space. Okay, so basically for the first experiment, the sample space can be listed HH, HT, TH, TT. Okay, this is the sample space. Okay, I have a container with Smarties, gula-gula coklat tu. Okay, coklat yang warna-warni tu. One red, one yellow, one blue color. If two students select one Smarties each, what will be the possible outcomes? Draw a tree diagram to show the sample space. Okay, if two students select one Smarties each. Well, maybe I should define the experiment more precisely. Okay, let's say I called two students to choose the Smarties. Let's say the two students will choose one by one, not at the same time. Okay, one by one. So that means when the first student choose the first Smarties. Okay, so basically there are three options. Okay, whether it's a red, yellow, or blue. Okay, and then the second student will choose another Smarties. Okay, so three more here for each options. So basically there are 9. The size of the sample space will be 9. Okay, you can try to do question 2 and 3 on your own. Okay, so basically that's the end of this PowerPoint slide. Okay, so I hope you will try to explore how to draw a Venn diagram and also tree diagram for today. Okay, thank you.